So reflections is the very last idea, and all it means is what? We're going to flip it, and then we might flip it about the x-axis, we might flip it about the y-axis. We kind of saw that already yesterday when we talked about odd or even functions, okay? So instead of using x squared, watch out, I mixed it up a little bit, we're going to use the square root function x on this example, okay? So if you remember, the square root function x, I picked perfect squares, right? And I can't pick any negatives because we can't pick a square root of negative. So I start with 0. What's the square root of 0? 0. And then 1's your next perfect square. What's the square root of 1? 1, right? What's the next perfect square we can graph, guys? 4, because what's its square root? 1, 2, 3, 4, go up 2. And then last but not least, what's the next one we can do? 9, because its square root is 3. So remember, he's kind of like this branch, and the reason why he works really well for reflection is since he is just one arm, you can see where we're flipping him, but we're like with a parabola, if you flip it about the y-axis, you can't tell that you flipped it, that kind of thing. All right, so the first one we're going to do is we're going to put a negative on the outside. Remember, anything on the outside deals with your y's, correct? So, if we're putting on a negative on the outside, we're changing our y's by negatives. Well, what were all of our y's? What kind of numbers were they here? They were all positive. So now what's going to happen? They're all going to become negative. So we don't even need to put this in our graphing calculator. Can we all agree that we're going to just graph the exact same x values, but with negative y values now, okay? So we'll be at 0, 0, 1, negative 1 now, 4, negative 2, 1, 2, 3, 4. And 9, negative 3. 1, 2, 3. There we go. So we just flipped him about the x-axis. All right. And then the only other reflection we can do is about the y-axis. And where's that negative going to go? On the inside. So think about it. We cannot take a square root of a negative number. So what kind of numbers are we going to want to plug in there so we can take the square root? Negatives, right? And so 0 will still be 0, correct? But now when we plug a negative 1 into there, that negative will compensate and it'll become a positive 1. So we'll have negative 1, positive 1, negative 4, 1, 2, 3, 4, positive 2, and then negative 9, positive 3. And we just flipped it about the y-axis now. Okay, so even though we didn't put it into our graphing calculator, we can see exactly what it's doing. Here it's changing our y values to negatives. Here we had to compensate by plugging in negative x's so that we could even do the function. So help me out. Can we fill out this rule? We sure can. It says y equals a negative f of x. So notice here's our parent function and the negatives on the outside. It reflected about what axis?
The y-axis.
Nope. So here is the negative we flipped about the x-axis. Do you see that? So I see how the negative's on the outside, and we were up here, and then we flipped them about the x.
So it changes the y but affects the x.
Remember, it's the opposite, and that's what we did with our symmetries yesterday. How did we test for y-axis symmetry? We plugged in a negative x. How do we test for x-axis symmetry? We plugged in a negative y. So it's always the opposite, right? So we changed our y values so it would flip about the x and become negative, or vice versa, right? So if we change in our x values, it's going to flip about the y. Again, so we can stay on the same y value, but our x's are going to change. All right, so we do have a last page on here, but before we get here, I just want you to know, how do you handle a lot of multiple transformations? You work from the inside out. What does that mean? It means when you see a whole lot going on, start as close to x as you can, do that transformation, then move your way out all the way. So what's the last thing we'll always do? That shift up or down, because it's always the furthest away from x we can get. So I'm doing okay on time. Let's see what's going on, okay? So here, I like to kind of label what do we have to worry about? Like, what is going on in this problem? And technically, we don't have to write our t-chart unless we want to, okay? So first of all, let's just say what parent function we're dealing with. What operation, not sign, adding, or plus, but what operation are we doing to x? You're cubing it. So our parent function is just the x cubed, okay? So I know I'm being really redundant, but if we're familiar with the x cubed function, this guy, we know kind of what we're starting at. So I'm going to go ahead and just write it down here so we just kind of have the original to look at. So that's going to be the very first thing we do, okay? So we'll have x, and we'll have f of x. And I'm just going to write it real quick, guys. It was -2, -1, 0, 1, 2. And we just cube all of them. And remember, when you cube a negative, it stays negative and so forth. So this will be -8, -1, 0, 1, and then 8. Okay, so let's just graph him first, and then we'll kind of talk about everything we're doing to him, okay? So -2, -8 is pretty far down. -1, -1's right next to the origin. Then we have the origin, then we have 1, 1, and then we have 2, 8. And I'm going to try to make it as curvy and snake-like as possible. Is that okay? All right. So what we're going to do, we have 2 transformations going on, thus that's why we have like 2 more graphs. We'll show the first transformation, get him kind of situated, and then we'll do that last transformation, all right? So right on this previous page, I made a note. What do we need to do? We need to work from the inside out. So we'll go here. And remember, when you multiply by anything on the inside, you multiply by the reciprocal. But what number is technically right there in front of the x? A -1, right? So what's the reciprocal of -1? -1, right? So anything that's on the inside and we're multiplying, we're doing the opposite. So technically we're dividing all of our x values by a -1. Or multiplying by -1, however you want to think about it. So multiply x by -1. So if you want to write a whole new t-chart, you can. Or just in your head think, okay, if I multiply this by a -1, what's going to happen to it? It's going to become +2, right? But have we done anything to the y's yet? No. So this point's going to become +2, -8, meaning I'm going to go over here now, 1, 2, and go down 8. And remember, I'm multiplying all these by -1. So when I multiply -1 by -1, what's he going to become? 1, but I'm not changing his y value. So we're going to graph +1, -1. When I multiply 0 by -1, does that change anything? No, so he's just going to be at 0, 0. And then notice down here, we had positive x values, but now what's going to happen to both of them? They'll become negative because we're multiplying them by -1. So we'll graph -1, +1. And we'll graph -2, +8. Do you guys see that? And if that's too much, you can write a whole nother t-chart. And actually, this is what I have in my notes, where I just wrote multiply by -1. And I just wrote all my new x values with the same y values. We didn't touch the y values, so they all stayed the same, okay? And if that's kind of confusing, it's kind of nice to do that if you want. Anyway, what did we do? Well, remember, anytime you multiply by a -1 on the inside, you just flipped about the y-axis, right? And that's what we just did. We just flipped about the y. We were here, and now we went bloop, like that. Okay, so then what's the only other transformation that we haven't taken account yet is this -4 on the outside. What's that doing to our graph, guys?
It's lowering it.
Lowering it how many units? 4. So down 4 units. So do you need to write a whole new t-chart? If you want to, you can. Or if you're really good about like making solid points, just go to what point you were at. We were at -2, 8. So now we're just going to go to -2, 4. We're just going to go down 4, right? So I'm going to go to 2, -2, and go down 4, which will get us at +4. And then I was at -1, +1, but I got to go down 4. So now I'm going to be at -1, -3. Is everybody okay with that?
Everybody, a whole two.
AKA the 2 of you that are in the classroom right now. Isn't that funny? I'm just so used to talking to a class full. All right. I think the easiest one, and I should have started this way, it's my fault, is that kind of that center, that vertex. So the vertex is usually at 0, 0, but we're lowering it down 4, right? So we're going to go down to 0, -4. There he is. Okay?
See what you're doing.
Oh, you can't? Am I too far down? Sorry, guys. Thank you. Thank thank you. Okay, so I was at negative 2, 8, but now I know I'm lowering down 4, so I went down 1, 2, 3, 4, so I'm at negative 2, 4. And I was at negative 1, positive 1, but I went down 4, so I'm at 1, 2, 3, negative 3 down there. And then I was at 0, 0, so now I'm just going down 4, and then it just kind of, the process continues. We're off the chart when it comes to positive 2, because we would be down at negative 12, but you have the idea, right? So positive 1, we were at negative 1, so now we're going to be at negative 5, and so forth. So you can draw that little half of a snake, and then remember that's going to just curve and go like that as well. And again, if you guys are in here and you're following me, okay, and you're nodding your head, but for anybody that's watching this, if this doesn't make sense, you can always just do your new t-chart. Have we changed our x's? No, our x's are still staying the same. But what did we do to each of our y values? We did minus 4 to each of our y values. And you get all your new values, right? So we'd have negative 12, negative 5, negative 4, negative 3, and 4. And those are literally the plots we put. We just can't get down there. All right, last one here, guys. Again, I don't know if you would really have to show it in all these steps, but it's kind of nice to just see it. Let me know when I get low and you can't see what I'm doing, okay? So what is the parent function that we're dealing with?
X squared.
Not x squared.
Or x root of x.
The root of x, right? The square root of x. So if you remember, that's the one we just did on the other page where it was just that arm, okay? So I'm going to graph him real quick so we know what he looks like. Remember, typically when it comes to square roots, you can only take square roots of positives, and I picked perfect squares. So we'll pick 0, 1, 4, and 9, because all their square roots are really easy to plot. 0, 1, 2, and 3. Okay? So let's plot him. Let's start with the original. 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, and then 9, 3. So we'll just plot him and talk about what we're doing there. All right, so there he is. So notice we have a handful of things that are happening to him. We have a minus 1 on the inside, we're multiplying by a 2 on the outside, and also multiplying by a negative. So on the previous page, we said work from the inside out. So we need to take care of this first, but anything on the inside is dealing with horizontal things, right? So what direction are we shifting this if it's x minus 1?
To the right.
To the right one, you got it. What does that mean? It means, guys, if you already have this plotted, you can literally just shift him over 1, or take our t-chart that we just labeled and add 1 to each of the x values. So we'll be at 1, 2, 5, and 10 now, but our y values of 0, 1, 2, and 3 will all be the same, okay? So we're just shifting 0, 0 to 1, 0. And then we were at 1, 1, but we're going to shift it to 2, 1. Then we were at 1, 2, 3, 4. We were at 4, 2, but we're going to shift it to 5, 2. And then we were at 9, 3, but we're going to shift it 1 to 10, 3. So you'll notice we just are keeping the shape, but everything's just been shifted 1 unit. Okay? Then this is how the book teaches it. So I'm teaching it like the book, but I'm going to give you the Molly tip once I do it. What they do when they come out here, they just do the 2 individually. Okay? So they do the stretch first, and then they do the minus that reciprocal or the reflection second. Okay? So what we're going to do is we're going to multiply y by 2. How do I know I'm going to multiply? Because the operation is actually multiplication. How do I know it's going to be the y? Because it's on the outside. So all I'm going to do is stretch each of these y values by 2 times, okay? So again, I'm just going to keep my x's the same. So x's will stay 1, 2, 5, and 10. But I'm going to multiply our y by 2. So I don't know, that looks like x. I'll put times 2 with a dot, times 2. So now instead of 0, well, that's still going to be 0. But then instead of 1, we'll have 2. Instead of 2, we'll have 4. Instead of 3, we'll have 6. So we're just pulling each of those y values, doubling them, okay? So we were at 1, 0. Guess where we're still going to be? 1, 0. And we were at 2, 1, but now we're going to double that. So it's going to become 2, 2. And we were at 5, 2, but we're going to double it. So now it's going to become 5, 4. And we were at 10, 3, but now we're going to double it, and it's going to be 10, 6. So So you'll notice you still have that rough shape of that half arm parabola, but it should be stretched vertically where it's being pulled upward. Okay, last thing, I don't think you should have to do this in 2 steps, but they want to really prove, okay, the multiplication of the number stretches or shrinks, the negative reflects. And so they're really trying to make that. But this is still on the outside, so we're going to multiply our y by -1, which means we're going to reflect it about the x-axis, because now instead of all these positive y values, we're going to flip it, and we're going to have a bunch of negative values. Oh, you guys are being good. You couldn't see what I was doing. Okay. So what I'm going to do, guys, now is just multiply each of my y values by a -1. My x's are all staying the same now that I've shifted them to the right one. So they're still 1, 2, 5, and 10. But now instead of any of these positive values, they're all just going to change to negative. So I have 0, -2, -4, -6. Okay? So 1, 0 was there. But then we were at 2, 2. But now I'm going to flip them, bless you, to 2, -2. And then we were at 5, 4, but now I'm going to flip them to 5, -4. 1, 2, 3, 4, 5. And then we were at 10, was it 10, 6, I believe? So we're going to flip them to 10, -6. Look at all that. Whee! And you did it. Phew! Before I stop, what I'm going to do is just double check that I graphed these right. And again, it's not going to be perfect because the view window is not square, but we'll have a rough idea of one, that we knew what parent function we were even dealing with, so we know the shape is going to be the same, and then a rough idea of, okay, its locations where it needs to be. Okay, so on this first one, there I am. Okay, y equals, I'm going to clear out that, and I'm going to just type it exactly how I see it. All right, so I have parentheses, the negative button's down here below your 3. Don't use a minus, use a negative. So parentheses, -x, parentheses, raised to the 3rd. So you just use your caret button and then the 3 and then -4, and you hit graph. So we're making sure we're using the right function. So the cubic function is a snake, but notice that it is kind of just flipped about and moved down 4. So we know we graphed him accurately. And then for the second guy, I'm going to go to y equals and clear him out. There's a lot going on here, but let's just make sure we have the -2 on the outside and then the square root. Depending on what calculator you have, I think you all have an older version like me, we're going to make sure we close the parentheses so we know x minus 1 is within that parentheses and close it off. So see how we're showing it. We know that x minus 1 is under that root. Okay? And I'm going to hit graph, and what you should see is it's just this arm that's been brought underneath, but it's stretched a little bit like we have. So we know we've done it the same.